The third law is the combined gas law. This combines both the Boyle's law and the Charles law, and it is used whenever the pressure and the temperature they change at the same time. So you have the pressure, you have the volume, you have the temperature. All of these they do change at the same time. The one corresponds to the initial state. The two corresponds to the final state. So a sample of hydrogen occupies that much volume at this temperature and this pressure. So when you're given like those three, you know that you have the pressure, the volume, and the temperature. All of those are changing. The most important thing to look for over here is simply your temperature unit. The temperature unit, as we mentioned, it has to be in Kelvin. If you keep it in Celsius, your answer will be wrong. So the first thing that you would need to do, you have to change the Celsius to Kelvin. Simply add 273 for each one or to each one of these temperatures, and you're gonna get the first. So the first temperature is 273. The second one is minus 15 Celsius. So this is minus 15 Celsius plus 273. You have to subtract here. So your temperature is 258 Kelvin, and this is your second temperature. Okay. And then we're going to state the given. So always make sure that the units are the same for the pressure and the volume. So your pressure is 760. This is your first pressure. This is P1. This is 760 torr. The second pressure is 950 torr. We can leave the unit as is because we can cancel the unit out. Okay. But if the units were different, you have to change them into one unit into both of them to be the same unit. So P1, P2, and then we go by V1. You are given 465 mils. No need to change this one into liters because you need to find the second volume, and they did not tell you to find the second volume in a different unit. So we're going to keep it in mils there. So here you go. You have everything that you're given. You have T1, T2, P1, P2, and V1. We know that P1, let's write it down here. So we know that P1 V1 over T1, that is equal to P2 V2 over T2. What we need to find is the V2. This is our unknown. So this is the unknown in there. So what we can do over here, this is the V2. The V2 is over here. So we're going to go ahead and, as we did earlier, we're going to cross multiply. So we're going to come up with another equation that says T1, P2, V2, that is equal to T2, P1, V1. No need to memorize. It's equal, I'm sorry, it's not underneath. That is equal to P1, V1, T2. Okay, and then I need the V2, so I'm just gonna go ahead and divide T1, P2 here and T1, P2 there. I can take out all of those, and then I'm going to be left with V2. So this is the formula for V2. It's V1, P1, T2 divided by T1, P2. And then I go ahead and substitute. Well, every time you substitute, include the unit so that you know that you are on the right track and you see the units canceling out. So this is 258 Kelvin divided by 950 torr multiplied by 273 K. So the K and the K cancel out, the torr and the torr cancel out, and your volume is going to be in milliliters. Let's have another example. So you're given everything in there. This is the gas sample. You do have the volume now. Now notice your volume is in liters. And you're asked to go ahead and get the second volume. They didn't specify the unit, so we're going to keep that volume in liters. you are given the pressure, and the pressure is in atmosphere. Okay, notice up there the pressure was in torr, but both of them were in torr, so I didn't have to change any. Here the pressure is in atmosphere, both of them is in atmosphere, I don't have to change any. But if one of them is in atmosphere, the other one is in torr, I do have to do a conversion in there. Okay, so if we go up, we did pull up the conversions for the pressure earlier, and this is the conversion. So 1 torr is equal to 1 millimeter Hg, and then 1 atmosphere is equal to 760 torr. Okay, so 760 torr is equal to 1 atmosphere. So this is what you need. This equation is what you need. Actually, it's not this one. It's this one what you need to change the atmosphere into torrs, and vice versa. Okay, so we can go ahead and we're going to use the same formula as we used earlier. So that is going to be for V2. So I'm just going to go ahead and write it down right away. So V2 is equal to V1 P1 T2 divided by P2 T1. You can have this in your cheat sheet. If you don't want to derive it, it's not a big deal. Multiplied by 1.8 atmosphere multiplied by 373 Kelvin divided by 303 K times 3.00 atmosphere. The moment in these problems, you know what type of formula you need to use. It's not supposed to be complicated. So it's just like choose the right formula and then substitute your given in there and then find your unknown. And that is going to be 1.85 atmosphere. The fourth gas law is the Guy-Lussac's law, and this law is whenever the temperature and the pressure, they vary at a constant volume. So you can see that the pressure is proportional to the temperature, okay? Because I can say over here that that simply P T is equal to constant in there. So as the pressure increases, as the temperature increases, because both are proportional to each other. And of course, this is for the same gas, okay? You're talking about initial conditions versus final conditions for the same gas. So an example over here, you do have at a temperature of 40 degrees, an oxygen container is at a pressure of that much. If the temperature of the container is raised by 100 Celsius, what will the pressure of the oxygen be? So you can see over here that they did not give me any information about the volume. So I am assuming that the volume remains constant. So I would change both the temperatures in there into Kelvin. So my first one is going to be the T1 here. So the T1 is going to be 40 plus 273. This is the 313 Kelvin. And T2, that is going to be 100 plus 273. This is going to be 373 Kelvin. So this is for T1 and T2, and then I am given P1 is equal to 2.15 atmosphere. My unit for the pressure here that I'm using is in atmosphere, so P2 I'm going to calculate that in atmosphere as well. And you know, whenever you have something like this, just go ahead and write the equation. So it's the pressure and the temperature, they are proportional to each other. So I would say P1 over T1. This is P2 over T2, and this is Guy-Lussac's law. So I can easily get P2 here. So I'm gonna go ahead and cross multiply, and I would say P2 T1 is equal to P1 T2. And then I'm gonna divide by T1 here, divide by T1 over here, and then get the P2. Go ahead and replace all of these, substitute all of these values. This is a 373 Kelvin divided by 313. K and K cancel out, and your unit is going to remain in atmosphere.